For our Engineering 305 data analysis project, we made an artificial neural network. The team members were Joel Yost, Courtney Brown, and Ryan Miller.
So for our project, we are training MATLAB to output an accurate identification of a number from a bitmap image given inputs on an image of either 0, 1, 2, or 3.
An outline for the project. So when we first started, we did a neural network process and bitmap manipulation, and then we also wanted to provide a mathematical model for a neural network, and then we'll show the MATLAB code that was used to train the data for the neural network and produce the right outputs.
And this is our bitmap manipulation concept map. So this is basically going to walk you through what our code's doing. First, we're going to load in the picture, and we're going to use a function to convert the matrix to only ones and zeros. And then we're going to find the top and the top corner and the bottom corner and delete everything outside of that that doesn't contain the number. Then we're going to use another function to resize the matrix to a standard size of 30 by 40. And then this is going to change the matrix from 1 to 0, so then we're going to have to convert it back to ones and zeros. And then we have to sum up all the ones in the columns. We do this by breaking the columns into 3 groups of 10 and then summing each of those column groups. And then we're going to sum all of the ones in the rows by breaking the rows into tens of groups of 4, and then we have to sum each of those row groups. And then we're going to sum the middle of the matrix, and then all that to build X, and our outputs are going to be 3 column sums, 10 row sums, and a middle sum.
So this is our process map for the neural network part of our project. The way we set it up, it took 14 inputs, sent them to 15 hidden layers, which is what we set it for the best results, and then sent those to the output layer, which chose whether or not the output was a 0, 1, 2, or 3. This is our mathematical model for our concept map. Basically, it just shows what was shown on the last slide. It describes it. So you have your 14 inputs, which are the X's on the left side, and each of those is sent to each one of the hidden layers to produce the equations shown in the bottom right. And then through those equations, it can choose which number each input is, and then output it as the correct number. So after our data was trained, we sent the data to the MATLAB neural network application, and the code on the left is the function that MATLAB output for us. On the right, you can see the confusion matrix. For the training, our program trained the data perfectly. There was no errors. For the validation matrix, you can see that our program was sent a 2 and guessed it as a 3 incorrectly. That was the only error for the validation matrix. For the test confusion matrix, there was actually 3 errors. There was a 0 sent to the data, and it guessed it as a 2. There was also a 1 that was sent to the program, and it guessed it as a 3. And then there was a 3 that was sent that was guessed as a 2. And those were the only errors that we had.
So now I'm going to walk you through our MATLAB code and exactly what that did. Alright, so here is how we trained our data. This first little bit right here, all this does is load our data, really. So like this first bit right here just loads our data. So it changes it every single time, so we didn't have to load it in one at a time. And then we just pull out the first sheet because it breaks it down into like red, green, blue, or red, yellow, green, or something like that. I don't remember exactly what the colors were, but we just pick one of them. And then we go through and we find the first one in the row and first one in the columns. And we find the last one in the rows and columns. And then next, we are going to take and crop it to those points that we had just found. that will give us our new size of just the number, so everything is equally sized, so the computer doesn't have to convert or have weird things in weird places. And then we can, after we resize it, we make sure everything is just in the zeros and ones, because as Courtney said before, when you do the resize right here, for some reason it renumbers a lot of things from zeros and ones to decimal points. So in order to make our code work the way we wanted it to work, we had to do that. Then we summed up the rows and the columns, and we then took and found three groups of 10 each for the columns, and had those be 3 of our X inputs. Then we had 10 groups of 4 for our row inputs. After that, we went and manually found where the middle would be, and then put that in as another X value. So we are now up to, I believe, 14 X values. After that, we went and built our X. So we put our rows first, then we put our columns, and then at the end we put our middle. So right here's where we put our middle. Then just to make it work the way we wanted to, we had to invert the X matrix, and then we had to build our Y matrix. So at the first 20, we had 20 pictures per number. So the first 20 we defined as being a 0. The second 20 we defined as a 1, 2, and a 3. And we did that by changing the row that it was in, so that the columns went down and across. So then we fed that into our function, and it built this, which I don't understand a whole lot. All I know is it goes through and finds out the percentage of each number that it's going to output. So
now I'm going to create our testing inputs by going into Paint, and we're going to hand draw 0. Doesn't matter how ugly it is. We're going to save that as our test 0. And then I'm going to create our test 1. We're going to save as test 1. And then we're going to have our testing 2 data. Title that as test 2. And then lastly, we're going to create our input for test 3. And then we'll save that as test 3.
So now that we have created our testing data, I'm going to go through and test them one at a time. This is basically the exact same thing as our training data manipulation script, except I removed it from doing all of the different pictures to just doing one picture at a time. So it's going to format it the way that we did in the other one, and then feed it into the function, and then find which number it is. So first one I'm going to test is the 0 that we created, which it outputs a 99.94% chance that it's a 0. So it's a 0. And then I'm going to comment that out, and then I'm going to run the 1, which gives us a 99.97% chance that it's a 1. So it's doing a really high probability that it is the right number. With the 2, it gave us only an 84% chance, which isn't extremely high, but I mean it's high enough to easily pick out what it is. So then I'm going to check the 3, which gives us a 76% chance, which is a little bit lower, but it's still plenty high enough for us to be able to very easily tell what it is. So now that we have done that,
So now that we've shown you that our program correctly outputs the right numbers, please feel free to give us 100% on this project. And have a great summer.